Hello everyone, welcome to BrighterBrainz. So our first topic is trigonometry. So in this class, we are going to discuss about introduction to trigonometry. So the introduction part now I'm going to give you who are the beginners or who don't know, who have zero knowledge about trigonometry. Just try to listen to this video carefully till end. Then you can get to know, you can gain the knowledge of trigonometry very well. So first of all, let us know the meaning of the word trigonometry. So trigonometry we can divide it as trigonometry. So tri is nothing but 3, is it? And gone is nothing but sides, and metry is measure. Simply measure of three-sided shape. We know that three-sided shape is triangle. So trigonometry is nothing but measure of the triangle. Measure of the triangle. Three-sided shape, that is triangle. So the measuring of the triangle is called as trigonometry, and mainly in trigonometry we are only going to deal with right angled triangle. Right angle triangle is nothing but one of the angle in the triangle will be right angle. Okay, so we are going to deal only with right angle triangle, and here any two sides will be perpendicular to each other. So now let us discuss about the parts in the right angle triangle. So mainly in this trigonometry, we are going to deal with the sides of the right angle triangle. So let us know what are those sides and all. Okay. So first, the opposite side to the right angle triangle. The opposite side to the right angle triangle, we call it as hypotenuse. The right angle triangle, which is opposite to right angle. The side which is opposite to right angle is called hypotenuse. Okay. Very good. And the next, let us consider one acute angle. Let us name it as A, B and C. Done. So let us consider the angle C, which is acute angle. So the side which is opposite to the angle C, or else the side which is opposite to the angle, that is theta. Let us consider it as theta. Theta is an unknown angle. Okay. So the side which is opposite to the theta is called as opposite side. Opposite side. And the side which is adjacent to the theta is called adjacent side. Adjacent side. Okay. So these are the common and basic thing which we need to know in a right angle triangle. Okay. So based on the angle also the sides will be changed. That is, for with respect to angle A, the opposite side will be this one, BC, and adjacent side will be AB. Okay. And hypotenuse remains same. Whether it is with respect to A or with respect to C, the hypotenuse will be the same. And hypotenuse, the side which is opposite to the right angle, and the longest side among all the three sides is hypotenuse. Done. So now with respect to A, the opposite side will be BC and adjacent side will be AB. And with respect to C, the opposite side will be AB and the adjacent side will be BC. Done. Till now it is clear, right? So in the trigonometry, mainly there are 6 types of trigonometric ratios. So in trigonometry, we are having 6 types of trigonometric ratios. So mainly those 6 types are sine ratio, cos ratio, tan ratio, cot ratio, cosecant ratio and secant ratio. So sine theta, cos theta, tan theta, cot theta, cosecant theta and secant theta. These are 6 types of ratios, and mainly these two, the first two, sine and cos, are the fundamental trigonometric ratios. These are fundamental trigonometric ratios. So the name itself can define that these are the main and fundamental trigonometric ratios, where other 4 trigonometric ratios are derived from these with the help of these 2 fundamental trigonometric ratios. So these 4 are derived from these. So these 4 ratios are called as derived trigonometric ratios. We can say like that, derived trigonometric ratios. Now it is clear. Okay. So the basic thing which we need to know is here the sine theta is defined, or else the sine theta is defined as the ratio of the opposite side to the hypotenuse is called sine theta. That is opposite side by hypotenuse. Okay. So I'm just writing in a shortcut. OPP means opposite and HYP is hypotenuse. And next cos theta. Cos theta is adjacent side by hypotenuse. And next tan theta. So tan theta is nothing but, so in terms of sine and cos, we can write tan theta as sine theta by cos theta. We know that the value of sine theta in terms of sides is opposite by hypotenuse, and the value of cos theta is adjacent by hypotenuse. So the hypotenuse will be cancelled out each other in the either denominators. Okay, so then the leftover part is opposite by adjacent. So therefore the tan theta is equal to opposite by adjacent. So these are the main sine and cos. You have to know this. Okay, so you should not forget these two related identities or formulae. And next tan theta is opposite by adjacent. And next cot theta is the reciprocal for the tan theta. So if cot theta is reciprocal to tan theta, then cot theta can be written as cos by sine, is it? The tan theta is sine theta by cos theta, then cot theta becomes cos theta by sine theta. Just simple. It is reciprocal to the tan theta. So if tan theta is opposite by adjacent, then cot theta becomes adjacent by opposite. Just like we are just reciprocal. Just reciprocal the tan theta, the value of tan theta. And next, these are the reciprocals of cot theta is reciprocal to tan theta, and cosecant theta is reciprocal to sine theta, and secant theta is reciprocal to cos theta. Just remember that, like you'll be confusing in the beginning you'll be confusing like sine, cos and cot, cosecant and cot, like that. So to remember blindly, just consider the first letter S. So in the sine theta, the first letter is S, and the alternate letter for that is C. Same as cosecant. We know that cos is fundamental one. So cos we don't involve this cos anywhere. So first consider S in the sine theta, first letter, and the alternate letter for that is C. Means sine theta is reciprocal to cosecant theta, and cosecant theta is reciprocal to sine theta. So sine theta can be written as 1 by cosecant theta, and cosecant theta can be written as 1 by sine theta. If sine theta is opposite by hypotenuse, then cosecant theta becomes hypotenuse by opposite, just the reciprocal to the sine theta. So remember that the first letter, if it is S, then the alternate letter will be the alternate lettered trigonometric ratio will be the reciprocal for it. And similarly, consider the first letter for cos, C. Okay, the first letter is C in the cos ratio. Then the alternate letter will be S, that is secant. So cos theta is equal to reciprocal of secant theta, and next secant theta is equal to reciprocal of cos theta. Okay, so we know that cos theta is adjacent by hypotenuse, then secant theta becomes the reciprocal of it, hypotenuse by adjacent. Done. Just simple. All these are simple, and mainly we need to remember sine theta and cos theta because these are fundamental ones. All the other trigonometric ratios are derived from these. So if you got to know clearly about sine theta and cos theta, you can derive all the other trigonometric ratios very well. So mainly we have to know this part to clear, to know all about, to do the exercise number 1 in the either NCERT textbook or in the state textbook. So these are the common basics which you have to know. Okay. So you can note down this sine theta, which is opposite side by hypotenuse, and cos theta, adjacent side by hypotenuse, tan theta, which is opposite by adjacent, and cot theta, adjacent by opposite, and sine theta is reciprocal to cosecant theta, that is opposite by hypotenuse, has been written already, and cosecant theta is 1 by sine theta, that equal to hypotenuse by opposite, and next cos theta is 1 by secant theta. Then secant theta becomes the reciprocal for it, that is hypotenuse by adjacent. All these are 6 trigonometric ratios which you need to know. These are the values of the trigonometric ratios in terms of sides. So after completing of all of this, let us discuss a single example so that you can understand very well and clearly. So until we do some of the examples, you don't get complete idea about the concept of it. So let us discuss one or two examples. Okay. So trigonometry, it is a very easy chapter, and there are no complicated calculations required here, because trigonometry, if you know the trigonometric ratios and if you know the identities we'll discuss later on, and if you know the identities and if you know the formulae properly, you can easily solve the problems. This is best scoring chapter if you practice well. Okay. Now we'll take an example. So let us take a right angle triangle. Let us name it as P, Q and R. Okay, let us name it as P, Q, R. And this is 3, this is 4 and this is 5. It is an example just. Okay. So I'm saying that in a right angle triangle, angle Q is 90 degrees and PQ is equal to 3 and QR is equal to 4 and PR is equal to 5. And the question is, find the values of all the trigonometric ratios, of all the trigonometric ratios. So all the trigonometric ratios, how many trigonometric ratios we are having? So 6 trigonometric ratios we are having. So let us find in an order sine theta. So, and I'm mentioning that this is the theta, or else listen. So if you want to find all trigonometric ratios with respect to angle R, sine R, where is angle R? Here it is. So with respect to R, we have to take the sides. So this is the opposite side to R and this is the adjacent, and hypotenuse will be same as usual, which is opposite to right angle. So hypotenuse is 5 and opposite is 3 and adjacent is 4 with respect to R. Okay. So sine theta is opposite side by hypotenuse, which is opposite side to angle R, PQ. PQ by, and next hypotenuse is PR. What is the value of PQ here? 3 and PR is 5. So 3 by 5 is the value of sine R. Next, let us find the value of cos R. Cos R is adjacent by hypotenuse. So the adjacent side is QR and hypotenuse is PR. What is the value of QR is 4 and value of PR is 5. And next, tan theta. Tan R. If we want to find directly we'll find with respect to sides, opposite side by adjacent side. What is opposite side? 3 and adjacent side is 4. And next, cot R. Cot R is nothing but adjacent side by opposite side, or simply it is reciprocal to tan theta. If tan theta is 3 by 4, then cos theta becomes 4 by 3. Simple. Okay. And next, cosecant R. Cosecant R is hypotenuse by opposite. It is reciprocal to sin theta. If sin theta is 3 by 5, then cosecant theta becomes 5 by 3. And next, secant R. Secant R is hypotenuse by adjacent. So if cos theta is 4 by 5 and the reciprocal for it is 5 by 4. So you can verify with this also, with the formula also, hypotenuse by adjacent. Hypotenuse is 5 and adjacent is 4. So these are the trigonometric ratios with respect to angle R. So let us find sin P, cos P and tan P. Let us find this. So now we are considering this angle, that is angle P. So with respect to angle P, the opposite side becomes QR. The side which is opposite to angle is the opposite side. So opposite side becomes QR, adjacent side becomes PQ and hypotenuse remains same, that is PR only. So sin P is equal to opposite side, opposite by hypotenuse. What is the opposite side here? QR by hypotenuse is PR. QR is 4 and PR is 5. Done. And cos P, adjacent side by hypotenuse. Which is the adjacent side? PQ by PR, that is 3 by 5. And tan P, that is opposite by adjacent, that is opposite side to P is QR by adjacent side is PQ, that equal to 4 by 3. Just simple. Okay. Just don't get confused. For every angle, you're not having same opposite side and adjacent side. So with respect to angle, the opposite side and the adjacent side will be changed, but hypotenuse remains same. Obviously, it is opposite to the right angle only, the side which is opposite to right angle, and it is the longest among all the sides. Okay. So this is a simple example.